Thank you all for coming out this morning. So I'm Jonathan Smith with Lakeflood Architects, and I'm going to talk about the sort of process and design side and how to convince your clients to do amazing things with water. And then Lee is going to give you the true story of what's working and what's not, and some lessons learned from the sort of more technical side of the process. So yeah, here we are. New Central Library, hopefully you all have been. It's gone from 800 people a day to 7,000 people a day using the facility, and it's we're really proud of it. So just a little bit of background. This is what Austin looked like when we were awarded the project in 2008. And that orange square there is the Central Library site. Which for you history buffs, as part of the original Waller plan of the National Capital of Texas, it was going to be the National Penitentiary site. We are on the banks of Shoal Creek and Lady Bird Lake in an incredible site. The city of Austin chose a really great site for the new Central Library. And water in many different aspects is huge to the building. So just a brief, this was a huge project with a zillion consultants. And so basically the way I tell it is it had every consultant that I've ever worked with except for a pool consultant and a blast consultant. But we had some really great integrated systems. We had biohabitats, which became natural systems on the project team, and they were really helpful. And then us and another architecture firm, Shepley Bullfinch, and I have the city of Austin right there with us because they were super hands-on and really involved. So there were 30 consultants, pardon my fonts moving around up there, and then with pencil Phelps. And then just a brief sort of timeline. This was a really long time coming. So basically, in November of 2006, the voters approved the new Central Library, and then we worked really hard and designed, and then it was under construction, and then it was complete in 2017. And a lot was happening within sort of designing a library at that time with regard to technology. When we started the project, everyone wasn't carrying around a library in their pocket, and by the time we finished it, they were. And so there was a lot of change happening, and also a lot of change in Austin. Right, you got another 500,000 people in the MSA in that time period. So then sort of to process. So on these large projects at Lake Flato, we like to get every single consultant and the owners in a room together like this, and any consultant that could have any impact to the sustainability of the building, we get them in the room with us. And this is all before we resist the urge to pick up our sketchbooks and immediately start sketching on the project and giving the project form and being architects, which is really hard to do for some people. And so everyone gets in the room together and we talk about the project and just set really big blue sky goals and see where we can get. And that's what led to the water system that we have in the building at the Central Library today. So we had 2 full days of this. And the first day we spent a ton of time in a room at the History Center setting goals. And the big goals that we set that day were to be the best daylit library in America, which kept me up many nights during the project, a hub for knowledge and learning, adapting gracefully to change, and then using potable water only for drinking and showering, and then a 64% reduction in energy and engaging the natural world. And the way that we talked about the water system for the building was basically as a water cycle. This is one of the early drawings from that charrette, and we originally wanted to have a completely closed loop. We wanted the rain that fell on the building to be used for everything, and we wanted to treat all of our black water on site. The constrained 40,000 square foot downtown site that we have on a creek barely above the lake level and creek level made the black water dream impossible for us on this particular site. But I'm really excited to see that dream becoming a reality in our new development services building, and I'm really looking forward to learning more about that. So that was the big piece that we couldn't accommodate. But so we drew this up about how the city water comes in and how the rain and the condensate would work, and we did a water balance calculation. And then the next day we went out to the site, which was hugely helpful. So for those of you who remember, before there were all these towers in the Seaholm district. This was the downtown substation where the library is now. And we were walking around, and if I can figure out how to do the pointer without turning off the whole thing, you can see there's some folks standing down by the bottom of the smokestacks there in that image. And there's a little sort of doghouse looking concrete building. And walking down into that, there is a big underground vault that the Austin Energy used for Seaholm. And we quickly realized that if we could use that vault, then all of our water storage problems on this super constrained downtown site would all go away. And so these are images of us testing to make sure the water actually stayed in the vault, and it holds 373,000 gallons of water. So every drop of rain that falls on the roof, every drop of condensate, basically through an awesome agreement with Austin Energy. We have to do a license agreement with Austin Energy, and we have to have a license agreement to go under the street, because this vault isn't even on the library's property. And it was really great, if you think about it, that a city-owned utility that has to deal with electrical was fine with us putting almost 500,000 gallons of water underneath all of their electrical stuff. So all the water goes over here, and then it's stored here, and then we have a buffer tank in the building where it's piped to. And then it goes to flush all the toilets, all the urinals, and does all the landscape irrigation for the library, as well as the landscape irrigation for Shoal Creek Park, which is another really great partnership. So a lot of city entities all coming together to make this dream a reality. I also just wanted to briefly touch on another side of the water story, in that we also used all native landscaping, and we have a green roof on the roof deck, which attracts butterflies, but it also means that with all this capture, we're also not having really any runoff from the building. There are a few roofs that aren't, immediately going into the system, but pretty much the total vast majority of the 40,000 square feet is either going into the green roof or going into the rainwater system across the street, which is really, really fabulous. And it is more fun technical issues about trying to put a large live oak on the roof deck, 6 stories above downtown. So there's your roof deck and kids playing. And there you can see the photovoltaic array. We got a 180 kilowatt downtown PV array on the roof. So then just finally, and I'll hand it off to Lee, so the current metrics, and these aren't the most up to date, but they give you a sense of those goals that we set early on. We're constantly in contact with Lee's team and looking to see how we're doing and testing those and making sure that everything is working out as planned. So we have, with regard to the water, we've got a 100% reduction in irrigation, obviously, because we're not using any city water for irrigation. That's all the rainwater. And then we've got a 40, I think actually more in these days, slightly more indoor water use reduction with our sort of low water usage fixtures, and then the fact that we're using all of the rainwater and condensate to flush toilets. And we just recently, as you all heard, we're the first city building to be LEED Platinum certified, which we're very, very excited about. And I'll let Lee take it over from here.
Good morning.
Good morning.
It's a pretty simple system, really. That's the main thing I want everybody to take away from today. I think I'm here more primarily to tell you, don't be scared. It's okay. Overall, this system is as easy or easier than taking care of a swimming pool system, quite honestly. So again, we collect it from the roof. It goes into the big tank by gravity feed. We then use a pump to pump it into our intermittent tank. And then we have 2 more pumps that alternate to send it throughout the building and throughout the irrigation. Again, just sort of some simple flow charts of the design. And this is what it looks like in real life. And these, this system sort of came pre-built on skids as well. That's one way to do it. This is a Bray system. And I'd never seen one of these before. I walked in and I sort of followed the pipes and went, okay, got it. There's not a whole lot to it. Comes back in, there's one little pump in the garage, brings it back in from the cistern, and then it goes into the, where did we find the laser? So it comes back into this room where it goes through the filtration right here. We've got a small filter there and then a larger filter down here, and that's the primary maintenance. Changing those filters, making sure they stay clean. And that is, like, we just watch that regularly because it varies. Since this is rainwater, it's carrying debris and other stuff in it as it goes. So those filters, they're there for a reason, and they clog faster or slower depending on conditions. So we just sort of watch that regularly. And again, this is our day use tank, and this is where our rainwater system meets our backup city purple pipe. If we have an issue, the pump goes down, a pipe breaks, filter clogs, and we haven't got another one on the shelf, anything like that. This tank is that intermediate tank, and right here is the city's purple pipe coming in with an air gap as to prevent backflow. There is no potential for cross-connect on this. They are entirely separate systems, the potable and non-potable. After it comes out of the day tank, it goes into this whole manifold system here. We have the pressure tank there to maintain constant pressure. We had a couple of issues with that early on. The bladder and that broke, which then we weren't maintaining pressure in the manifold, and we had some pipes break. So those are, you know, little things you learn along the way. We've had to replace one of these pumps. It just, you know, manufacturer out of the factory defect, so replaced it within a year. And then here, the water all comes down and gets split off into these 4 branches here, which are irrigation and our toilets. We are running about an 85% offset in terms of potable, non-potable. So we're only using about 15% of our total water is potable, which is amazing. We were doing a little bit better than that, and then the cafe at the library got finished and came online, and food services, you can imagine, they're going to use a lot more water. So yeah, some of the lessons learned. Anticipate startup issues. There's always startup issues on any project. If it's part of an initial construction, you roll into the project, it's a little easier. If it's an add-on after the fact, then it's going to require maybe a little bit more focused thought about those things. How do you measure? How do you know how well it's doing? Thinking about those things. Ours is tied into our building management system, so we just have data points feeding into that. Gives me a dashboard. One of the big things that I've heard back from people a lot, especially as I've given tours on this system, is how invested I appear to be, and my team as well. And I think that's a big part of it. The operators on site have to care. I could just shut off the pump and close some valves and have all this water supplied by the purple pipe and not use any of that rainwater. But I'm a tree hugger, so I don't. And that is it.